Are you interested in having a stable temperature measurement from the sintering zone, analyzing the influence of the main burner flame on quality, anticipate clinker quality changes, having information about temperature distribution over the time at the sintering zone, burner tip and coating, finding always the optimal main burner settings, analyzing emission changes in their correlation to the main burner flame, increasing the alternative fuels rate? If you answered yes to one of those questions, have a look at PiT's thermography PiT indicator. PiT indicator consists of an optical sensor on a retraction unit and a sophisticated software. It provides you with thermographic images and a video. The optical sensor is mounted on an automatic retraction unit which retracts the sensor in cases the sensor is in danger of getting damaged. This sensor consists of an endoscope protected by a high alloy steel tube which is entering the kiln. This tube is cooled by air or water, and the endoscope tip is kept clear by purging air, building an air bubble in front of the protective lens. The light beam goes through the endoscope and is splitted to a digital camera with an onboard PC and the video camera. This housing can be water cooled as well. To control the temperatures, air and water flow, as well as the retraction unit, the system comes with a field cabinet, which even can contain a monitor to show pictures of the flame. The PiT indicator comes as well with a system computer and a sophisticated software. Process control data can be displayed within the software with a process connection. Temperature measurements and threshold values can be written to the PCS. An internet connection allows for direct service of PiT specialists via remote control. But let me show you some of the capabilities of this product more in detail. The PiT indicator shows videos, a screenshot here on the left, and as well a thermographic image here on the right. In the middle, you see a comparison with a pseudo-color picture produced by an outdated technology. The PiT thermogram is a matrix of totally 440,000 quotient pyrometers, and the result, the temperature, is shown as an individual color in the matrix. Each color reflects the temperature as the scale on the right is showing. Blue colors are around 800 degrees Celsius, orange colors are around 1400 degrees Celsius, and white colors around 1800 degrees. This clear picture can be achieved through a patented electronic dust filter. Let me introduce you to PiT's digital image processing in rotary kilns using the adaptive electronic dust filter to reduce dust impact on pictures. In a typical rotary cement kiln with a grate cooler, the burnt clinker is dropped onto the grate. Secondary air from the cooler is used for heat recovery reasons, but it as well transports dust from the cooler into the kiln, disturbing the view on the flame. Harder or hotter burning causes more dust. Images get dark, and classical pyrometer's temperature drops. PiT's integrated shutter mode acquires high-resolution pictures with varying exposure times from 1/10 of a second to 1/10,000th of a second. An extensive image source is collected over the time, and the sophisticated software makes a selection of the 25 pictures taken per second. The AEDF selects those pixels offering the best contrast and brightness. The selected pixels are merged into a single image, which becomes the information source for RGB thermography and pattern recognition. Depending on the dust load, a new picture is shown every 1 to 10 seconds. Let me now show you how you can read the flames and read temperature development over the time. For this, PiT invented the polyline. The thermographic image is measured along a selected area termed polyline. Those lines, which can be straight lines or polygons, are drawn onto the thermogram to measure, for example, the flame diameter and flame length, as well as the plumb and ignition point. The polylines are automatically transferred to a time axis every second as the image updates. With the passing time, the copied polyline indication scrolls to the left as the most recent polyline is entered at the far right position of the axis. The same thing is done with the other polyline, indicating burner tip temperature, plumb length and ignition point. The resulting chronological display of the local temperature distribution offers a fast and reproducible geometric indication of the main burner flame patterns as well as of the conditions in the sintering zone and the clinker bed. Even smallest flame variations are visualized. The time axis can be changed, and so the polylines can be displayed in this diagram over a few minutes or even over days. This is how it looks like in real life. This customer has installed a burner with two tubes, one for the primary fuel and one for the alternative fuels. As you can see, the polylines are moving from right to left and are indicating a massive change in the flame. The upper polyline shows the vertical flame diameter, and the lower polyline is bended and shows the coating, the flame diameter, and the lower burner tip temperature. Those graphs show the mean temperature of defined regions. These regions are defined in the image as squares. The red line shows, for example, the mean temperature of region 1. This customer has installed a two-screen solution. On the right side you see the flames as a thermographic image. On the upper left screen, the average temperatures of the defined regions are indicated. And on the lower left screen there are two polylines. The upper one is showing the horizontal line and the lower one is showing the vertical line. Though this customer only burns coal, you can see how there are changes in the flame. Here the flame is smaller and cooler, here the flame is wider and hotter. You as well can see that the plumb is getting longer over the time. So, what are these polylines good for? The first thing is they show changes over the time. Another thing, besides finding optimal burner settings, is that you can monitor fuel changes and their development directly. This customer, for example, used 100% pet coke, and you clearly can see coat formation and flames ignition point in the polylines. When this customer changed operation to 50% pet coke and 50% solvents, the coat formation and flames ignition point changed significantly. The coating was burned off and the ignition point went nearer to the burner. If we change the slides, then you can see the comparison very clearly. Another issue polylines are used for is to see the influence on process values before they are measured in the clinker and it is too late to react. To do this, PiT offers the possibility to connect to the process control system and to display PCS values in the polylines. This example shows in the upper polyline coal, fluff 1 and 2, and tires over 1 hour. As you see, the flames started getting smaller and smaller because less coal was fed, and the compensation with fluff 2 did not work out. The operator could have seen this in the polylines and could have reacted better, but he did not. Additionally, there was a drop in fluff feed due to a mechanical problem. The operator reacted immediately and increased the coal feed to get the flame to normal shape again. As soon as the mechanical problem was solved, the operator increased fluff 2 again and decreased coal. This time he reacted to the polylines and used them to find the right amounts. The lower diagram shows the NOx measurements and O2 at the chimney without time correction. The NOx peak is measured about 15 minutes after it was produced at the flame. This clearly shows that the polylines together with the process values can be used to optimize the process and to react earlier. The PiT indicator is not a dead-end solution, but is upgradable to several other PowiTech products. I will not show you all products, but just the typical upgrades. In plants having a high alternative fuel rate, a very typical upgrade is the PiT indicator side view, which is mounted at the side of the kiln head. This position allows for a side view on the plumb, and especially on the plumb of every fuel type separately, as well as on the flame diameter. If you want to have more information on the PiT indicator side view, please have a look at the separate movie. For plants having a fully automated burner, the PiT Navigator burner adjusts the burner fully automatically according to the information gained from the flame and from the process control system. The PiT indicator's cooler shows snowman, filling degree, and temperatures in the cooler. The PiT Navigator cooler is for optimizing and stabilizing the cooling process and increases throughput. The PiT Navigator sec air is especially focusing on the secondary air coming from the cooler and influencing the flame massively. The combination of burner and cooler control leads to a stabilized sintering process of 25%. The PiT Navigator for the whole sintering process is able to follow contradictory targets at the same time. If we have a short look at the results of PowiTech products, I do not want to bore you with the result of all our products and to refer to separate presentations, movies or brochures. One example which I would like to show are the results of the PiT Navigator, which can achieve -6% fuel consumption, a secondary fuel rate of over 80% at the main burner, +7% clinker production, +35% stability, and this all at the same time. So, who uses this superior solution? Well, the global players and market leaders as well as the smaller family-owned cement producers. There are over 100 cement kilns worldwide equipped with PowiTech system, and customers like Holcim and Lafarge are distinguishing the product as the best available technology. Let me summarize the capabilities of the PiT indicator. The PiT indicator delivers a clear thermogram through its adaptive electronic dust filter. It is an intelligent monitoring software which is modular, user-friendly and easy to customize. The polylines help you anticipating process changes and to analyze them over the time. You can do active flame management and react faster to changes. With a quick adaptation of fuel changes, you can stabilize the process. The view on the coating allows for coating management, and the influence of the flame enables increased emission control. If you now want to buy the PiT indicator, please contact us. You as well can receive much more information like articles, brochures and information about our intelligent products on www.powitech.de.